challenges and solutions. So a little bit of context, and I'm sure many of you are aware of this, and this won't be a surprise, but all nicely set out by the Heat and Buildings strategy that was released last year. So a third of the UK's carbon emissions, roughly, these are all rough numbers, are attributed directly to the operation of buildings. Of that, 2/3 is heating the buildings. And of that, 3/4 is domestic homes, and the remaining quarter is non-domestic. So the single biggest objective in terms of impact for decarbonising the operation of buildings is addressing heat. And it's no surprise, and people will have read, and some will have much deeper levels of understanding than others of the role that heat pumps have to play in that. But rest assured, it's quite a large role. But there are a lot of myths and indeed mistaken bits of information out there, particularly in the popular press and the broadsheet press, that we read sometimes as practitioners with slight confusion and annoyance. And I think what this session is about really is assembling some experts from the area to talk through what the challenges are, what the answers are, and to really try and hopefully for everyone lower the hurdles and improve understanding as you take this agenda into your projects and your work. So we've got three fantastic speakers today. We have first up will be Emma Fletcher, who was a key client at the Swaffham Prior Heat Network, which is really a fantastic project involving supplying a whole village with heat from heat pumps. Thomas Lefebvre from Etude, who are sustainability engineers based in London and do a lot of great work on this area. And Jez Climas, who's the head of renewable heat at Midsummer Energy, who are suppliers of heat pumps as well as many other renewable technologies. So without further ado, I will hand over to Emma.
Many thanks, Joel, and afternoon, everybody. So for many of you, you probably have heard of Swaffham Prior in the proximity of Cambridge. It's a project that has been started by the Community Land Trust, but we're working alongside the Department for Business, Energy and Industrial Strategy, very closely with Cambridge County Council, and also we have had some funding in the past from the Combined Authority. So Swaffham Prior is 8 miles east of Cambridge. We've got approximately 800 homes, a large conservation area, 40 listed buildings, and quite a large number of affordable homes versus the whole population. And the one thing that we are all reliant on is either heating oil or electricity. None of the village is on gas, and therefore we have to look to alternative sources. So the aim of the project came on the back of building some homes to the village, and it's to replace the oil boilers and electric heating with renewable district heating. We believe we're the first to do it at a village scale retrofit level, and the idea was there'll be no barriers to entry and that we can achieve high temperature water around the whole village, regardless of the type of property that you occupy. So the project has been evolving as Joel said, over the last 4.5 years. It works off a remote solar farm, which is about 8 miles away with a private wire, 120 ground source heat pumps, an industrial air source, and that takes hot water around the village. So if you imagine the energy centre is like the heart, we've got a series of pipes as valves and, as arteries and veins, and that takes the hot water around the village to people's houses. Once it gets to their houses, they have a heat interface unit, and a little bit like an umbilical cord, the hot water going around the village transfers the heat onto your private network inside your home. So this is the field. We've got an 18-acre field. It was tenanted by a county council tenant. It did have a nitrogen fixing cover crop on it. And as part of the project, once the boreholes are in, it's going back to the tenant farmer and will be part of a wider village rewilding project. So these are a number of the boreholes out on the field one frosty morning. This is them a bit closer up. We haven't struck oil or water. The drilling process does require an awful lot of water. These pipes are going down about 200 meters and are installing the closed loop system. As I said, we have about 120 of these boreholes across the field. They're spaced at 20-meter intervals to stop permafrost or the pipes nicking the heat from one another. And they will be our primary source of heat during the summer. We also have an energy centre, and inside the energy centre, we have 3 large air source heat pumps, and we have a series of pipe networks around the village. So 7 kilometres of pipe are going around the village, really well insulated, taking the hot water to people's homes. So in each home, there'll be a heat interface unit. So this is the heat interface unit. So instead of an oil boiler and a big oil tank in the garden, this individual heat interface unit will just sit on a kitchen or in a utility wall. They can also go outside as well. And this will basically bring the hot water to your home, and it will connect to your hot water system inside the house and also the central heating. We price matched that this project would always be cheaper than oil, and we price matched at 45 pence a litre. For anybody who is currently on oil, you will suddenly realise that the prices when you order your oil to fill your tank have gone through the roof. Incidentally, my brother-in-law, who normally spends £400 on a regular oil delivery, has just been quoted £1,600 for his oil delivery. So the cost of oil has gone up disproportionately, literally in the last couple of weeks, and is causing massive issues in terms of fuel poverty for many homes, especially in rural areas. So we've been working alongside the residents. This project has been evolving. As mentioned before, it was one of possibly the first of its kind, or at least the first of its kind we know of, dealing with lots of different ownerships in a village setting. And one of the first things we learned was we had to look professional. So what we've got is we've got a community liaison person to assist us. We've got a logo, we had newsletters, we went around the village, we took the heat interface unit to people's homes. We've done a walk with the engineer around the village. We've really spent a lot of time working with the residents, telling them about the project, telling them it's coming, and explaining to them that this is very different. This is a high heat network. As I say, it's 75 coming out of the energy centre and 72 degrees guaranteed to their home. For the last 3 years, we've had heat monitors on 3 different types of homes. That data is live streamed out anonymously on the County Council website. And all this information that we've got is benefiting other communities. But it's safe to say nobody really knew what our heat demand might be. So we've been collecting that data, which is now available for others. One of the real key drivers for us was also working with the housing associations. As mentioned, there were 40 plus housing association homes in the village, and actually the cost of living even 4 years ago was high on oil, but now is absolutely crippling for many of the households in our village, and therefore this project couldn't come quick enough. The overall impact is to save over 1,000 tonnes of carbon. It's to be cost neutral for those who want to join, so everybody can join regardless of their home. But also there's 10,000 other householders in Cambridgeshire that we know could benefit from this. And so far we've engaged with over 50 different parish councils, local authorities, regional development agencies who are interested in rolling this project forward. But is everybody happy? And the problem is, this is the rub. Not everybody really wants to change, and not everybody realizes that their lifestyle is going to have to change, whether it's our project or them doing it themselves. Residents, both tenants and private for sale occupiers, are going to have to do things to their homes which are disruptive, which are going to have to see them making cost and significant cost inputs into their home to ensure that they actually reduce the amount of energy they're consuming. For some residents, we've had people thinking that just because they've bought from a renewable source, that's their bit done. And also, you know, everybody thinks that they can install an individual air source heat pump just into their existing home. But we know there are challenges surrounded by that, especially with listed buildings, conservation areas, and other planning issues. So we've also got a face up to Facebook. This is our village Facebook notice board. It's quite an interesting place. And resilience to getting these projects through, I cannot even stress how hard it is to bring people along with you, but also to try and encourage others to stick with the project. So this is a couple of snippets from the village Facebook page. For example, any negative story is used as a way of thinking maybe the project shouldn't go forward. So last week, the seismic activity stopped drilling at the Eden project. Well, someone's tried to compare that to the village. The difference is they're going down 4.5 kilometres and we're going down 200 metres, which is about the depth of most Anglian water extraction pipes. So it's not comparable, but people are using evidence to try and say this shouldn't be happening. There's also a lot of people that are getting upset over the traffic management, and that is a legitimate issue. Providing traffic lights as we're installing the pipe network through the village has caused chaos, especially when they stop moving or if people pinch the batteries. Again, sort of outside of the project's remit, but in terms of having to deal with these issues, we spend a lot of time trying to address traffic lights and address minor issues that impact on a day-to-day in order to deliver on the main project. And then we've got blamed for an awful lot of things as well. And you'll note the bottom one there, we're not responsible for a whole load of other things that happen in the village, but people are very quick to blame the project for other things like pavements that are problematic, etc. So resilience and actually keeping talking and keeping informing is a key thing in terms of delivering on a project like this. We also have the odd article in the Daily Mail written by a journalist who lives in the next village who had also got fed up sitting at the red traffic lights, as we all had. And this article was posted both in the paper and online. But however, what is very, very telling is the comments in the comments box. So if you look, and this is slightly out of date possibly, but people basically poo-pooing the environment and the need to change. So we can't afford this eco stuff. The green policies will cost us all in the future. We must get these people out. And that scores highly in terms of the readership. Unaffordable, crackpot green projects, etc. However, the person that says they're backing the project, they equally get but a higher number of negatives from the readership. So actually trying to encourage the man, the woman on the street, the readers of the Daily Mail to actually change their ways is going to be a key issue. And the final thing is that actually this is coming. And how do you genuinely explain this to the man and the woman on the street, the slightly older generation who think that they will be dead by the time they need to change their ways? And then a very important document that not many people read that came out for consultation, which closed January this year, is that actually, if you look closely in the small print, the government wished to stop all all oil boilers being installed from 2026. That's not whether it's a new build, this is all oil boilers. Whether you've got one at the moment, to get a replacement one, you won't be able to do it. And I think this needs to really be passed over to general members of the public, that life has to change and it has to change quickly. Thank you.
And with that, thank you very much, Emma. With that, we'll hand straight over to Thomas, please.
Thank you, Joanna. I'm going to share my screen. Can you see this? Okay, thank you. So good afternoon, everyone. I just wanted to start with a fairly, not graphically designed cover, but just to, that's what we are talking about, really. We need to move away from gas as quickly as possible. I think a lot of people are talking about 2025, 2026, but the sooner we do this, the better. And I think anything we can do to stop the installation of new gas boilers from now would be a decisively good step in the right direction. I work for Etude. We're working on 80% of our work is on building projects, residential projects, small or large, non-residential projects, but we do about 20-25% of our work is on policy. And I see that Emma Davis is on the call. So hello, Emma. We've worked with Bioregional and Emma on the Greater Cambridge Local Plan, which is very relevant to the discussion today. And we've also worked on a renewable energy analysis for the island of Bermuda. And if I may, I just want to echo what Emma said. As part of this exercise, we had to engage with the public quite a lot. And of course, we had to deal with, the minority who tends to be really disruptive and vocal on social media. But we also realize that the largely silent majority is very, very in favor of those changes. And I think it is the case for decarbonizing heat as well. We have to learn to engage with the public positively, but there is a huge level of support out there for these moves now. I just have 3 slides on the context. I think most of you have seen probably 1, 2, 3 of those slides before, but it's really important that we keep on reminding ourselves, what's happening and why we do this. So this is the, carbon intensity of 1 kilowatt hour of electricity. And, we obviously know now that 5 years ago, electricity has become lower carbon than gas, and it's predicting to be even lower carbon. So that's why this move away from gas now is so critical, because the gap will ever only increase. This is an extract from the Climate Change Committee report, and it's looking at how we need to decarbonize over the next 30 years. And you see the kind of greenish wedge here. It is residential low carbon heat. And this bit here is the non-residential building scale low carbon heat. So, more than half, of our way to decarbonize, more than half is this challenge of heat that Joel is talking about. So it's absolutely critical that we do something, and quite quickly. And this is another extract looking at, the expected uptake of, the expected uptake, the uptake of heat pumps that we need to deliver this. So there's a direct connection, if we want to decarbonize and deliver this, then this needs to happen. And we all know that the numbers look quite scary compared to the kind of 20,000 pounds to 20,000 heat pumps a year we used to. But this is what we are trying to deliver. So I'm going to talk about different challenges, solutions that we come across, over the last 3 years on projects. I think none of this, there's not a single answer to some of these challenges, but I'm going to throw some themes out there. So the first one is there's a huge variety in the type of heat pumps. So here it's a diagram which we've done for a report for the Greater London Authority a few years ago, and it's looking at different scales of heat pumps and different types of heat pumps. And most people, when they say heat pumps, they mean one type. And actually, we need to acknowledge that there's quite a variety of heat pumps, and especially for the complex projects, it's 100% worth taking the time to consider which type is available, and then compare them with each other. So the first message for me is really important, for complex projects, that there's not a single heat pump solution. There are different solutions, and we need to compare them as fairly as possible. When we do those type of comparisons, and I'm sure it's the same for everyone, we of course look at capital cost, we look at carbon, we look at running cost. And it is actually quite tricky, because here I think for a master plan of about 800 new homes, these are all the solutions that with the MEP engineers and the client we agreed could be doable on this project. So this was their baseline, a kind of district level air source heat pump with still 30% coming from gas, which we wanted to fight against. And then you've got different types of systems, either communal or individual air source heat pumps, or even ground source heat pumps. And towards the bottom here, you've got just direct electric system. And we need to be able to quantify the benefits of those different solutions quite objectively, so that the client and the project team can take a decision. Here we found out that the ones highlighted in green, and we had 2 communal options, 2 individual options, were the lower carbon ones. But as you can see, the gap is not as massive as when you compare to a purely, gas-based solution. One thing we're constantly finding on projects when we move to stage 4 is the importance of distribution losses when heat is distributed at a temperature of, say, 60, 65, 70 degrees. So here we're looking for a scheme of about 60 units, and it's just, air source heat pumps on the roof, distributing heat at 60 degrees to heat interface units. So we're not talking about a district heating network. It's a fairly simple building level distribution system. And this is the split of energy consumption for a typical home per square meter. And in this particular case, you could see that the proportion of losses from the heat interface unit, and in particular the communal pipes, are really significant. So more and more with heat pumps, we're going to need to be really careful about not wasting heat by distributing it at too high a temperature. Energy cost is a growing concern, and it has always been a concern behind the move to heat pumps. Interestingly now, of course, with the gas crisis, we're seeing a shift where suddenly heat pumps are not only seen as the scary new solution which may increase energy cost, which is always a kind of a myth anyway. But one great thing about heat pumps is that if they're integrated in a way which enables the home to make use of dynamic pricing, it could actually be a fantastic way to cut down on the energy bills and make the most of the time when electricity is lower carbon and lower price. And the other, I think, big thing which is, slowly being realized by everyone is, as we need to contribute, towards more renewable energy generation, there is going to be more and more renewable energy generation on our roofs. And our ability to make use of that electricity generated by the solar PVs to cut down our energy bills is going to become more and more important. This graph is showing the ability of a PV array to significantly cut down this energy bill, either because solar PV is either directly used by the home or through the exports. And I think another challenge of heat pumps, which I wanted to talk about, is the issue of refrigerant. So on one hand, we've got significant international agreements which create a very good framework for refrigerant not to become an uncontrollable environmental impact of heat pumps. There are some clear directions of travel in terms of phasing out some refrigerants. On the other, there's still a lot we can do on projects. So picking up the right refrigerant is, of course, an important one, but also, finding ways to minimize the refrigerant volume. And, more and more people are starting to quantify the embedded carbon of heat pump installations. So, of course, the type of refrigerants and their volume, have two clear implications on the embedded carbon. And finally, so we're seeing on projects a desire from architects, finally, to not only fight against the integration of individual heat pumps, but seeing ways to integrate them. And hopefully we're going to see that more and more. So, communal heat pumps for blocks of flats are generally located on the roof, and they're easier to integrate. But more and more we're seeing smaller blocks of flats, 8 units, 12 units, who for the type of projects for which a communal system may be over the top in terms of maintenance legacy, to try to find ways to integrate heat pumps at an individual scale, feeding each apartment. And I personally, I love the look of a heat pump, but I don't think it's the case of everyone. And these are 2 attempts to hide them without disrupting too much how they work. So yeah, lots of different themes. I wanted to share with you some of them, and I'll hand over to Joel.
Thanks, Thomas. That's fascinating, and hopefully very, very insightful for many people. I think that's a perfect tee up for Jez to talk through his experience supplying heat pumps to the mass market, and the challenges that he comes up against. Jez.
Yeah, hi everyone. Yeah, I'll just get my slides up. All right, there we go. Yeah, so hi. For those of you who don't know me, I think a lot of you do. I'm Jez. I used to work at Max Fordham in Cambridge, working on a whole load of college projects and university projects and various other things. And a year and a half ago, I resigned to come and be the head of renewable heat at Midsummer. So probably not many of you have heard of Midsummer. But so what Midsummer is, it's a renewable energy wholesaler based in Cambridge. Company 16 years old. It started off as an off-grid PV installation company when the founder Andy fit PV to his boat and then his neighbour's boat, and then it kind of grew from there into grid-type PV installations. Then started wholesaling, became a fairly big solar wholesaler. Was one of the early ones on batteries and EV charging, and then Andy persuaded me to join to start doing heat pumps as well. And so we're now a kind of full spectrum domestic renewables wholesaler, as well with the PV it scales to commercial as well. And yeah, we're based in Cambridge, and 55 people working for us now, give or take, and turnover about 40 million a year at the moment. So it's a pretty significant company, just taken on new premises in Cherry Hinton. So what we do is we wholesale renewable energy products to installation companies, who then install them on people's homes for the most part. So I'll kick off with the heat pumps. Now, the first thing I wanted to say about heat pumps, which is absolutely critical, that is so often just misrepresented for no good reason, is people always say, oh, you need to have a really well insulated home to have a heat pump, which is completely untrue. The heat's got no idea how much insulation's in the wall. Your heat pump extracts heat from the air. It puts it into the water in your heating system, which circulates around radiators typically. The heat comes out of the radiators into the air in your house, and then from the air in your house, it goes out through the walls back out into the outside air. So that's what the heat's doing, and all you're doing is pushing it through that cycle with a bit of electrical energy. And as long as the total amount of heat going into the house is no more than one heat pump can produce, the cost of the installation doesn't get crazy high. And obviously this heat transfer from radiators to house, that's kind of a pinch point in this process. So if the radiators need to be very big, then that can be kind of practically problematic. And so that's where a very poorly insulated house can be difficult. But there's absolutely no reason that a heat pump can't heat a badly insulated home. And it is absolutely better to meet an unnecessarily large load with a low carbon method than with a high carbon method. It's better if you can reduce that unnecessarily high load in the first place. But if for whatever reason you're not doing that, it's not okay to just shrug and go, I guess we'll just keep the boiler because the heat pump won't work. So that's a major bugbear of mine. The heat doesn't know about the insulation. But so this presentation is a fairly nuts and boltsy presentation about the kind of day-to-day practical challenges of the heat pump retrofit job, and also about the kind of organizational challenges and the skills challenges. So this slide is taken from a training presentation I've given to a few solar companies, explaining to them things they need to go through with homeowners when they're selling them a heat pump, if they're moving into heat pumps from solar. So I thought it was a good one to introduce here, because the key things that an average homeowner who's got a boiler has to deal with is that they've got to give up some outside space for a heat pump, and they've got to find a spot for it, and that might be something that they're not super keen on, but it's a fact of life. they will have to find a space for hot water storage, which they may already have if they've got a cylinder. But a lot of houses now, over 2/3 of houses have combi boilers, so a lot of people now don't have space currently allocated for hot water storage. So they're going to lose that space. The radiators may have to get bigger, and we'll talk a bit more about that later. So they may have to have some radiators removed and replaced with bigger ones. Another thing is people will have to culturally get used to low temperature heating and weather compensation, and the slower response that their house has, that you can't let your house get cold and then try and heat it up fast. It won't be good for the heat pump's efficiency. And then the last thing is they go to a single utility bill, and that this slide did until very recently say single bigger utility bill, because there was a real danger that with a heat pump you could end up actually paying more for your utilities. But now, actually, fairly recent development, the new price caps, it's now just definitely going to be hundreds of pounds a year cheaper to run a heat pump, unless it's really awfully installed. So with even average luck on the quality of the installation and the COPs achieved, it should be cheaper to run. So another thing on space, I used to do schematics which had a load of symbols on back when I was a consultant, but for the installer market, it's much easier to give them a photo. So here's a heating schematic with a load of photos of bits of kit on it, but you have to find a home for all of those, and they're not all to scale here, but it is more stuff to fit in the house for the most part, and there's nearly always a bit of a loss of space inside the house. And now people have done some things where they've put these things in pods that can be dropped down outside the house, and that's fairly common actually in the Netherlands. When they retrofit heat pumps, they'll drop these pods in outside everyone's house and then just connect the pipes up through the hole that the flue used to go through. But it's yet to catch on in a big way here, so most of the time it's a loss of space. And then low temperature heating. I mean, low temperature heating is more of a cultural issue than it is a practical one, in that, so heat pumps are most efficient if you can run them at lower temperatures. And the lower temperature you can run them, the more efficient they are, and therefore the more carbon savings you get and the cheaper they are to run. Now, what that can often mean is that the radiators in a house aren't big enough, and there's a huge variability on this. Speaking to some of the bigger heat pump installation companies that we sell stuff to, they reckon on average they replace about a third of the radiators across all the mixed housing stock that they put heat pumps into. But some houses that's practically every radiator, and some houses it's none. In fact, Joel's dad's house had a heat pump retrofit, one of the first heat pumps I sold, and that was a fairly new home, I think only 10 years or so old, and none of the radiators needed replacing, and the heat pump runs at 45 in the very coldest conditions. So it's not usually too much of a challenge, but it can mean some radiator replacements. But the main thing is it means the heating is on for longer, and I always kind of liken it to making pulled pork. It's a gentle simmer. It's a low, slow, just gently pushing enough heat in to overcome the losses. And actually, anybody who's done this, and there's kind of increasing the encouragement to people to test this, because if you've got a combi boiler, you can normally just turn down the flow temperature and see how it works. But it's actually nicer because all the surfaces in your house get evenly to the air temperature, and you don't have convection currents, hard convection currents churning around as your radiators are at 75 degrees. You get less radiant asymmetry, and it is actually just better to have low temperature heating. But it's difficult to persuade people that it's lower energy and more efficient to do it, because the natural logic of their brain is, if my heating's turned off, then I'm not consuming any energy for heating, and then when I turn it on, I am during that period. But actually, you've got to meet the overall heat loss of your home through the day, whether you meet that in a short period or a longer period. And turning the heating off and letting it drop by a degree or two doesn't massively reduce the heat loss. It just means you're having to put that heat in a much shorter time. So the other thing heat pumps do, which boilers should have been doing for a decade but very rarely have, is weather compensation. And that means that the flow temperature of water into your heating is lower when it's warmer, so that it can go along all day running at 30 degrees to meet a smaller heat loss, as opposed to running at 50 degrees for 2 hours to meet that heat loss. And the reason this is so critical is because, roughly speaking, for any given set of external conditions, a heat pump's about 3% less efficient per degree hotter you make it run. So everything you can do to get your heat pump running a degree or two cooler makes quite a big difference. 3 degrees is 10%. It's a big deal, and that's why you run it constantly. So it's just putting in enough heat, and it's why you weather compensate as well. So one of the challenges of the heat pump retrofit is the kind of skills gap in dealing with a slightly more sensitive heat source. So at the moment, if you call up a heating engineer to come in and give you a replacement boiler, they'll kind of walk in, they'll look around your house a bit, think for a moment, and then they'll choose a boiler that's over 30 kilowatts routinely, regardless of the size of your house. They might go up to 40, might be 28 at the bottom end if you've got a very small house. And actually, with gas boilers, there's not terrible consequences to massively oversizing them. So they do cycle more, and that does cause a lot of efficiency, and they produce a lot more heat than they need to, and heat up the heating water in your house very quickly and turn off. And the real efficiencies of gas boilers, it's turning out, are pretty poor. It's just very rarely ever measured. But it becomes clear when you've got a heat pump that's got monitoring, and so you know the exact amount of heat that you're putting into the house after the heat pump retrofit. And then you look at what that must have meant for the boiler efficiency, and it turns out lots of boilers with badged efficiencies of 92% are actually running at more like 70% efficiency, and sometimes even worse. But nobody ever really noticed because gas has been so cheap, and it's been such a small part of their expenses, and they've never had the data to analyze it. But so in the case of heat pumps, you're kind of required to do, for an MCS heat pump install, you're required to do a room by room heat loss calculation and heat emitter check to make sure that, firstly, the heat pump is big enough to meet the whole load of the house, and secondly, that the heat emitters in every room, whatever they are, will put enough heat into that room to maintain it at the temperature it needs to be. And that's very important in the case of heat pumps, because whereas with a boiler, oversizing it doesn't have terrible consequences, with a heat pump, it can be problematic, because if you make the heat pump twice the output it needs to be, it's bigger, and they're already slightly unnervingly big to some people when they got their outside space to give up, and they get noisier, and they get more expensive, and they get less efficient because they suffer from cycling in the same way that boilers do, but actually they kind of suffer worse effects from cycling a lot. So this is so in new build, the heat emitter output's required from a kind of paper calc, and so it gets a bit easier. So some of you will have done heat loss calcs. Most of you will be familiar with the concepts. But yeah, you've got to do the fabric loss, so conduction through all of the surfaces of the house, ventilation loss, which is warm air leaves, cold air comes in, the leakier your house is, the more that is. And then you've got to design condition, sum them up, and get the heat pump size. But this is a bit of a lost skill. So back in the early days, it's interesting, I've learned some of the history of the kind of central heating rollout in the UK. In the early days of the central heating rollout, British Gas went around fitting gas-fired central heating to loads of people's homes, and they did do heat loss calcs, and they did try to select a boiler that was no bigger than it needed to be, because they were very expensive at the time. And that was all done properly, but it's been lost now. The combi boiler means it's not a necessary skill anymore, and nobody does it. And so it's very difficult now to skill up the industry of sole trader heating engineers. So the MCS has split the certification into a designer and installer certification, although it's still a bit clumsy. So me, as a chartered engineer with 15 years experience of designing heat pump heating systems, would have to go on about 5 days of courses to become an MCS certified system designer. And I'd have to learn things that would be of no use to me whatsoever in that role. So that's a problem. So I think this is probably the biggest challenge, is this kind of conversion of the industry from the sole trader model to a model where people can skill up. Because the sole trader model, apprenticeships aren't popular, and even when they are, people only kind of learn from the person who they're apprenticed to, who may not have these skills. Then the other issue is, so MCS certification's a hurdle for those sole proprietors, so that a lot of them are very scared, maybe, or certainly can't be bothered with the effort of training up as heat pump installers and getting their MCS certification, which is a lot of paperwork and a lot of annual capital outlay to maintain the certifications. And so at the moment there's over 120,000 gas safe register members and less than 1,200 MCS heat pump installers. So there's a hell of a long way to grow the workforce to do this retrofit at the scale it is needed. Now, in the same way that with the gas central heating rollout, that was largely British Gas, and it was driven by a small number of large organisations. I think you'll see a bit of that with the heat pump rollout. So E.ON, Octopus, OVO, and other large organisations are, so the companies who did the smart meter rollout as well, all these organisations are looking to have large heat pump install teams. If you add up all of their ambitions for heat pump installs, it adds up to way more than is actually needed. So someone's gonna crack it, and I think there's gonna be a big push from these big companies, and then you'll probably get the same thing that happened with British Gas, that some people come out of that as sole traders, having picked up all the skills working for the bigger companies. And then what we're doing at Midsummer, we've made this software heat pump, because I know how to design heating systems and do heat loss calcs. So we've made this free software heat pump, which you can use at heatpump.co.uk, which is aimed at lowering the barrier for smaller installers to do these calculations themselves and do all the paperwork, and give them less desk time and try and get it closer to the kind of working practices that they're used to doing gas boilers. And that type of innovation, there's going to be more of that about, and more people filling in the skills niches. There will be people training up as heat pump designers and just working with installers who then spend more time fitting. So then kind of chat about equipment and the development in equipment at the moment. It's very interesting because, yeah, Thomas talked about refrigerants, and that's a thing that's moving on. And I think there's a hell of a lot of cost in R&D for a manufacturer to move from one refrigerant to another. So in fact, the unit pictured there is that's a Stiebel Eltron WPLA07. So that uses low global warming potential refrigerant, which is R454C, I think, with a global warming potential of 148. But Stiebel have spent a hell of a lot of money on that, and they've said to me it was an eye-watering amount of R&D that was much more than they anticipated when they started. But they've got them running, but that refrigerant's only available on their smaller units, and they're still doing the work to get it into their larger units, which are still running on older stuff. Now, a lot of the equipment is from air conditioning companies, and you're seeing kind of an interesting commercial situation arising here, in that Samsung and Mitsubishi and Daikin and Panasonic are all companies that have been doing air conditioning for a long time, but haven't had any presence in the kind of Northern European heating market where people have wet heating systems. But actually, it wasn't loads of effort for them to make air to water heat pumps. It's a slight change from their air conditioning kit. Not to minimize it too much, but it wasn't a big change for them. But then there's the incumbent heating companies who don't want to lose their hundreds of thousands a year of boiler sales. So they're all having to start doing heat pumps as well. And yeah, the two have got these different market positions where they're now starting to compete. yeah, it's fascinating, and they do business in quite different ways as well, which if you talk to me in the pub, I can talk about for hours, but I won't bore you with it now. But yeah, so they're all ramping up because demand's sky high. Italy's now paying 110% of costs, and for these types of retrofits, and so in Germany it's ballooning. All across Europe, demand is climbing sharply, and indeed in the UK. Now at the moment, this stuff's fairly expensive, especially relative to the air conditioners that they are often quite similar to. And that's pretty much just due to the small quantities. So the Samsung factory puts out about 1 or 2 air-to-water heat pumps per 100 air conditioners it produces. And they have to retool the production line for 1 day every 2 weeks to do all the air-to-water, and then they flip it back to air conditioning again. And compared to the boilers, it's still a small amount, and they're spending, there's a hell of a lot of R&D money to be soaked up amongst a relatively small number of units right now, especially compared to boilers or air conditioning kit. And another thing that comes out of that is that at the moment, installation and commissioning it's more bother. Now many boilers that you buy, you can scan a QR code on it with your phone and then commission the boiler via a phone app in about 5 minutes. We're still not at that position for the heat pumps. It's still developing, and sometimes you have to kind of wade through a menu of badly translated Japanese to commission one. And then lastly, I'd say the other thing that's strange about this market at the moment is we're kind of in that early adopter phase where the people getting into it and getting heat pumps are largely keener people who are very particular about what they want and have read about all the different heat pumps and have been on forums and Twitter and are being very specific about what they want. And so a lot of installers aren't being able to kind of get in the groove of churning out a thing repetitively that they like installing and they've got the hang of. And they're getting a lot of customer bespoke request. So the de-bespokeification of the heat pump rollout, I think, is going to be a key thing. And more commoditization. But at the moment, I got an installer saying to me, this person said they want brand X of heat pump. Those aren't available right now because of the chip shortage. I've told them they can have brand Y of heat pump for £1,000 less, and they said no, I definitely want this one. I'm willing to wait, and I'm willing to pay an extra £1,000, which doesn't happen in a lot of markets, and it certainly wouldn't happen with boiler retrofits, I don't think. So it's an interesting. I think we're at an inflection point in the market where it's moving from that early adopter phase into a more mainstream phase, both as a result of equipment developments and consumer choices. So, just quickly, a thing to say about permitted development. So at the moment, a heat pump is a permitted development in England. There's different rules in the 4 countries of the UK. So this is just England. There's similar rules in other countries. But to be permitted development, you have to do a crude noise calculation, which any acousticians in the audience would cringe at. The physical volume has to be...
Jeremy, just to let you know, that's going to be my hook to try and move you on.
Yeah, no,
we have questions from acousticians.
Last slide. The physical volume limitation of 0.6 cubic meters, which is a bit of a problem, and 1 meter from the boundary, those are competing requirements. It's easier to make a heat pump quieter if you make it bigger, because you can put more sound shielding in and run the fans slower. And people do sometimes ignore the size and boundary requirements. Now over to Bob.
Hello, everyone. I've just been asked to speak for a couple of minutes about my experience of having an air source heat pump installed at my house. I've lived in my house for 24 years, and I only had it done 2 years ago. I had an oil-fired boiler. I was spending something in the region of £1,200 to £1,500 a year on oil. And the main criteria for the installation was it had to cost less than that to run. I'm pleased to say it costs a fair bit less than £1,000 in electricity a year. I've got quite a big 5-bedroom detached house. And I suppose one of the key criteria if you're going to do this, you have to have the capital outlay in the first place. But I am getting a renewable heat incentive paid back quarterly over 7 years. So in 7 years' time, the amount I will have actually spent is actually quite small in comparison to the cost of the installation. The equipment was installed in March 2020 at the beginning of the lockdown, so we all had to learn how to keep away from each other, which was not particularly difficult. I've got 16 radiators and about 15 square meters of underfloor heating in my house. They ended up changing 4 of the 16 radiators, which were older ones, and they made them the double thickness ones. It runs off the Wi-Fi. I've got an app on my phone where I can control the temperature. It's exactly as Jez says, it doesn't, the radiators never feel hot like they do with oil, where you can barely touch them. But the whole idea is to keep an ambient temperature all of the time. But it does work. It's warm in my house. In fact, my family think it's warmer, mainly because I was so mean, and when oil costs such a lot, I used to keep turning it down when they weren't looking. But now I've figured out that you can't do that with an air source heat pump because it relies on a constant supply of a lower heat. I get free servicing every year because I have to get them one new customer each year, and then they give me a free service. So I'm very happy with that. Although the servicing only costs £100 or so apparently. And I don't bother to monitor it that closely anymore, but it definitely uses significantly less cost of electricity than it does in oil. And the main thing I've got to say, which Joel instructed me to say, is they work. Thank you.
Thanks, Bob. I don't know how close you were on your 2 minutes to say heat pumps work, but I think that pretty much did the job. All right, guys, that was fascinating, and you know, without almost accidentally, I think we had a really coherent breadth of experience there, rounding up with Jez in the nuts and bolts and some of the very specific issues that are facing the wider rollout. And I think before I sum up, I might just go and jump straight onto that, Jez, with a couple of questions that are coming around. And the first one's going to be about noise, actually, and this comes up repeatedly. And I think you started to touch on it, and I might turn to Bob as well. So yours specifically, I'm going to ask Bob about his experience, but yours, Jez, how it's taken into account how noise is taken into account in the air source heat pump selection process. I think this is quite a quick answer.
Yeah, so there's a standard calculation, MCS 020, where you assume a 45 dB background sound level, and you then do a crude acoustic calculation for the effect of the heat pump's noise at a neighbour's window in an occupied room, and it has to be below a certain target. Now, what's bad about that is it doesn't take account of reverberant fields, and if you're surrounded by buildings, it doesn't take account of real background noise level. So if you're in a very quiet rural location, you'll definitely hear a heat pump that passes that calculation, whereas if you're facing onto a busy street, the heat pump could be 10 dB noisy without anybody noticing. So it's not the kind of acoustic calculation that this panel's used to from commercial projects, but I think it necessarily has to be simple for the case of individual retrofits. And
I'm going to pass straight on to Bob there, actually, because this is exactly the calculation that your installer would have undertaken, Bob, and you're in a reasonably quiet rural location. And I would just ask you your subjective experience of noise from your heat pump.
It makes a pleasant little hum, Joel. My neighbour is about 10, 12 meters away, and there's a hedge and a bit of land going up, but he was a bit worried about it to start with, but he says he never notices it. And there's actually, you've got to find the right location as well. So having had an oil tank, we've just got ours sort of around the back of the house where there's no windows. So it's just filling that space. Nobody really knows it's there.
And yeah, I'm going to bring Thomas in and then move on to Emma with this one.
Yeah, I mean, just quickly on the noise, you know, of course, the planning system needs to worry about it, and of course, you need to have calculations. But I think I would encourage anyone who hasn't listened to a heat pump to see an installation, because it's much less noisy than you think. Especially the modern system, the latest monoblock systems. They're very, very, very quiet.
And for Mike, just sort of piggyback on that ever so slightly, I do quite a lot of work in large grid scale air source heat pumps for heat networks, and went to visit a scheme in Denmark with a client, and they were taken back by how quiet it was. And it was almost like all of the consultancy that had preceded the visit was totally pointless, because all you needed to do was stand next to it and realize it wasn't very noisy. And that'll lead me on to Emma's question to the disruption of installing a very large heat pump in terms of traffic was discussed. Emma, has there been any issues with noise from plants? And
to be fair, we did what you do with the normal planning application. So we had a full application, background ambient noise. So we have far more needed than just for a small domestic installation. We also had the option of putting the fan bed in the far side away from the home. So we have one home that's nearby, but actually then we've got about probably at least 150 meters to the back of people's gardens, and then the homes beyond. So we have got some distance, but we did take into account prevailing wind as well.
You have the advantage of space. But a couple of very specific questions while we're with you, Emma, on the if you know them or not. I think some of the information is online for this. The diameter of the boreholes, the diameter of the primary network, the pipes in the primary heating network, and the flow and return temperatures at your installation.
Start backwards. Flow and return, 75 degrees out, 55 in. The pipes are 20 centimeters diameter, plus the insulation on top for the main feeds going in. And then the small individual household pipes go down to a dual pipe that's insulated. So 2 pipes in and out with insulation around. And those little pipes are 2 centimeters diameter each. So there's a variety of sizes that come down, and the holes into the ground are about, again, 20 centimeters down, with 2 pipes that just go into Middle Earth.
And I'm going to apologize to Fernando, who asked a very sensible question about what the industry's readiness for maintenance requirements. And I think mostly because you slightly touched on it, Jez, and indeed Bob. Emma Davis asked if anyone could give any top tips for individuals looking to pursue heat pumps in light of everyone's experience. I'll ask you to be really quick so I can do a little bit of wrapping up. I'll go through each of you. Let's go Jez first.
Yes, I would say, do speak to your installer and try and quiz them about why they're choosing the model of heat pump they are and where they're proposing to put it. But I think it's very difficult because most homeowners have little understanding. So you can do a bit of research, but there's more misinformation out there than information, I think. So it's kind of like any other domestic trades people. Spend a lot of time talking to them, get a few to look at it, and see who you find most convincing. I think it's one of the things that's most difficult, actually, is finding the right people. I've got personal recommendations if anybody needs to ask. But
I would second that, Jez, from my personal experience. Emma, top tips for people wanting to completely radicalize the energy strategy for an entire village?
So for us, it's lack of ability to put kit anywhere. We have listed buildings, we have a conservation area. This solution solves a whole village scale. And I think human psychology comes into this. How do you get mass change when things like RHI are disappearing? So that's the benefit of our project, is everybody changes together and you get mass change and less disruption to the home.
And Thomas?
I don't know really. Jez covered a lot of it. I would say, I think go for a simple system from a reputable supplier, unless you're passionate about heat pumps and engineering.
That's a very, very sensible suggestion. So sorry to rush you off, Thomas. I've got a minute, and I did want to wrap up, if that's the case. So I'd like to thank you all again. That's absolutely fascinating. I've actually learned some stuff today, as well as many others who've been listening in. Emma took us through this 200-meter deep boreholes, the 7 kilometers of pipe, and that's nothing compared to the complexity of getting residents on side and dealing with social media. And it was interesting to see that Nigel Farage's new pet project aligns well with the Daily Mail post, which is a fascinating sort of insight. There's a big challenge and a whole range of options to address it, as Thomas set out really well, and that the details very important to make it work and realize COP. There was some great real data there from Interface to look at the impacts of dynamic pricing and interfaces with PV generation, which are almost, I would say, the next step along the journey for this, for most individuals looking at this. And Jez took us through a lot of the nuts and bolts of installing heat pump space, connections, radiator sizes. I mean, it's a third of houses have combi boilers. Roughly 30% of radiators are increased in size. That compared with Bob's 25% of his radiators that increased in size. And I also learned a new word from Jez today, which was de-bespokeification. And on that, I'd give a special thanks and wish you all the very best. And do contact members of the panel if you want to discuss any of this further, because we're all very, very passionate about this agenda. Thank you very much.